All right, guys, we are here for another note video for physics, this time talking about Newton's second law and working out the math examples from the notes. So Newton's second law, we're going to hide my face again. Here I am, person, here I am, or there I go. Bye-bye. Newton's second law is kind of complicated to remember. However, hopefully I will give you a trick to remember this. First law says an object does not change unless there's a net force acting on the object. Any force causes an acceleration. Masses have inertia, which resist this change. So we're going to combine this all together. I get this really awful complicated phrase down here. Accelerations are produced by a net force on an object and are directly proportional to the magnitude of the net force in the same direction as the net force and is inversely proportional to the mass of the object. Most of you know this law as F net equals mass times acceleration. Another way to write it, and unfortunately it got all jacked up whenever it got imported from the other location. I'm just going to zoom in and write it right here. Acceleration is equal to F net divided by mass. I just rearranged this formula to get acceleration all by itself so we could see the relationships between net force, mass, and acceleration. If you remember your relationships from math class or from the beginning of this class, since F net is in the numerator, it is directly related to acceleration. As that net force gets bigger, my acceleration will also get bigger. But since mass is in the denominator, it is indirectly or inversely related, which means the bigger my mass, the harder it will be to accelerate my object. That's all second law is. So remember, if you know how to read equations, equations are just saying ideas in symbol form, in shorthand form. So don't overthink this law. So a few things we need to know to calculate acceleration is net force and mass. So you're going to have to draw free body diagrams to calculate net force. That is a value you're going to need to know for these problems. So now I'm going to walk you through the math problems that are in here. Calculate the horizontal force. So we are looking for the force needed to make a 1 kilogram hockey puck accelerate at 1,000 meters per second squared. Go through and label things. I'm looking for force. They gave me kilograms, which is a mass. And I know I'm trying to accelerate it this much. Lucky for me, I have an equation that includes all of these values. So 1 kilogram times my hopeful acceleration of 1,000 meters per second squared. The net force needed to accelerate that puck that much would be 1,000 newtons in the same direction as the acceleration. They didn't specify in this case, so you don't need to worry about it. All right, hopefully that seemed easy. The next one, it'll get a little bit more challenging as we go. So calculate the acceleration. So now we are looking for acceleration of a 100 kilogram cart when the net force on it is 50. I am going to use this same equation, and I am a big fan of rearranging the equation before plugging in numbers. If you want to go ahead and plug in numbers now, you super can. So I'm going to get acceleration all by itself, since that's what we are looking for. Acceleration is F net divided by mass. So I'm just going to plug in the numbers I know. Net force is 50. Mass is 100 kilograms. It looks like that makes my acceleration 0.5 meters per second squared. Great. Now, as I promised, we have 2 more examples, and they're going to get a little more complicated as we go. So a 2 kilogram crate is pushed horizontally with 50 newtons of force, while 12 newtons of friction oppose the crate's motion. I would start by just drawing a picture. Oops, that is not as flat of a line as I want it to be. So 2 kilograms, horizontal force of 50 newtons. They didn't specify which way horizontally, so I'm just going to draw it to the right. 12 newtons of friction. Friction typically opposes motion and goes in the opposite direction, so I will draw 12 newtons going the opposite way. What is the acceleration of the crate? I know that looking for acceleration may trigger some memories from projectiles and kinematics that we need to pick out a scary acceleration formula, but that is not the case here. I am in forces, and I really only have one equation with acceleration in it to figure out acceleration. And that is my second law equation. Acceleration is net force divided by my mass. Now, I know to find acceleration, I need to know net force and I need to know mass. Lucky for us, the problem gives us mass. They don't give us net force, but I can calculate net force by adding together all of my forces. Now, these aren't all of the forces acting on this object. I'm missing gravity and normal force. But guys, let me tell you, most of the time in this class, you will see an object just resting on a surface like this, resting on the floor. And if it's moving sideways, that means it's not accelerating up or down. So I can assume the force of gravity and the normal force, or all of my vertical forces, are balanced. So there's no change vertically. So what's really nice is I can kind of ignore those, because when I add those together, I get 0 newtons vertically. So my net force can be calculated. I'm going to use a different color. Not that way. Very different color. Sure. Net force can be calculated by adding together my remaining forces. So I'm going to say my applied force plus my friction force. But since my friction force is in the opposite direction, I'm going to make it negative. So this is an example of a net force equation, the other net force equation you can have. On your formula sheet, the other way to calculate net force, other than to multiply mass and acceleration together, would be to add together all of your forces. And remember, you should add only in the horizontal direction or only in the vertical direction. If you combine the two, you're going to have to do trig, which is totally possible, just doesn't happen very often in this class. So you are going to kind of make your own equation based on the picture you draw, based on the free body diagram you draw. So in this case, I made this equation because I'm combining the two remaining forces I have that are not balanced out. So the other way I can calculate net force would be to plug in 50 newtons, my applied force, minus 12 newtons. When I plug that into my calculator, I get 38 newtons to the right. And now I can plug that into this equation over here. So 38 newtons, I'm going to write to the right so I don't forget, divided by 2 kilograms. So I get an acceleration of 19 meters per second squared, but which way is that acceleration occurring? Always in the same direction as the net force. Those are directly related to each other. So the acceleration will be in that same direction.